Okay, I think we may have resolved the issue now. Um, Sorry about that. It seems there was a mix-up. I'd already begun with my with my presentation on a separate stream, but it seems like it is now working. So we shall bear with it. I'll just double check that it's all coming through correctly, uh, and we're good. Okay, so something has gone wrong, but it's now okay again. So I'll begin from the beginning. Sorry about the delay starting there. Um, okay, awesome. Hello. My name is Joe Robbins, and I'm a field engineer at Unity. Um, some of you may know me. I may have popped over to your studios. If not, maybe I will sometime in the future. Um, the idea today is to go through some of the elements of the Unity particle system. Some people just double checking that everything seems good. Okay, everything seems like it's working. Fantastic. Okay, so yeah, the idea is to go through some of the particle system stuff. I'm going to basically give an overview of how it all works. I'm going to go into detail into some of the new and more interesting modules that have been added. And I'm also going to go over a bunch of the stuff that we have coming up in the pipeline. I'm going to talk a bit about performance optimization, because obviously with particles you can easily go a bit wild, and it's important to know that there are ways to optimize things. So cool. I shall begin. So what you should be seeing now is the Unity 2017.3, and I have a strange sense of deja vu because this is exactly where I was a second ago. So let's begin. So if I go to Game Object and I go to Effects, I can create a particle system. So by default, Unity creates a very basic system with just some very basic settings set up for you. So here it is right now. And let's go over the basics. So when you're modifying particle systems, you do it all in the inspector view, which is over here. Turn up the mic volume. Okay, I'll see what I can do. I just noticed that. Hopefully that's a little bit better. Okay, so hopefully the mic's a little bit better there. Let's see how that goes. Okay, right, let's continue. So the particle system by default, all of the options that you have are available to you in the inspector. So when you're doing the majority of your editing, this is where you'll do it all, really. So by default, you have the basic settings, then you have the emission, the shape, and a renderer enabled, just to give you something to kind of start with, I guess. But I'll go through some of the basics just so you're kind of familiar with what you're looking at. So up at the top here, you have a bunch of different options which are kind of universal to all particle systems. So they don't quite fit into any of the other modules, but they're useful nonetheless for everything that you're doing. And something worth noting is that a lot of these have quite a lot of options to them as well. So for example, I could modify the start speed here and give that a value of say 10, which would allow the particles will be a lot faster by default. However, there's a lot of granularity with the options here. So not only can you modify just the value here, you can also choose multiple options as to what that value is going to be. So for example, you could have the start beat set by a curve, or even like a random between two constants. So for example, I could have the speed of the particle be either somewhere between 1 and 10 to achieve that kind of view, that kind of an effect. Equally, you could also have a curve to define how that looks, and the curve editor kind of sits down at the bottom, so you can kind of put it out of the way if you don't use it, or bring it up if you want to use it. And you can also have a random between two curves. So there's a lot of flexibility with the options that you pick, and most of the options inside the particle system does have this kind of drop down, or one similar that gives you options that you should take a look at. It is worth noting that generally the further down you go, or the way you look at it, is that the performance that you're going to get is going to reduce. So I guess you just using common sense with this one is worthwhile, but having a random value between two curves is going to be a little bit less performant than a constant, and having a random between two constants is going to be slightly less performant than having a constant, and so on. But generally it's pretty obvious as to what's going to be faster and what's not. Another thing worth noting is the color picker here, which has a bunch of different options. You can choose, say, a color, a gradient, random between two colors, random between two gradients, or a random color. For this, I'm just going to set this to a gradient for now, I think, and just show you the gradient editor. So you can have a whole range of different particles from in different colors. You can use a blend. I'm sure you're probably familiar with the gradient editor inside of Unity. But you can do a blend, but you can also do a fixed gradient, which is great for defining a bunch of different colors. I've got a default one set up here with just a bunch of different colors, and then it cycles through and spawns particles within those different color groups as they go through. Okay, so that's the very, very basics. So if we go and have a look at some of the modules in a bit more detail, I'll then go on and kind of highlight a few after then. The thing with the particle system is that there's kind of a lot to play with, so it's kind of one of those ones where you'll want to just kind of spend some time noodling around and seeing what kind of effects you can create. Just for the sake of it, I'm going to pop some gravity on these particles just to make them slightly more interesting. So yeah, next module down is the emission. So any of the modules that you have enabled, you get a little tick box next to them. Emission is as you'd expect it is, basically. It's got a bunch of different options. You can change the rate over time. So it's currently set to 10. So I could say reduce that down to 3, or whatever I'd want it to. I can also change the rate over distance, and I can also change and add bursts, so bursts of particles at set intervals. So for example here, by default, it creates one with a timestamp of 0. So at 0 in the particle's life cycle, it will spawn 30 particles, and it'll do that once, and you can set the interval if you have multiple cycles throughout the life cycle of the particle. It's also worth noting as well that you can add multiples of these, so at various different times you can trigger a whole bunch of different bursts. It's also worth noting as well is that there is a toggle for looping up in the top here. So if you do want to do like just some kind of basic explosion effect and you don't want it to loop, looping is a good way of turning that off and on. Whereas if you do want to loop, some kind of smoke effect or something, that's toggleable there. Okay, so that's emission. Shape, next up on the list. It's had a few interesting additions recently, and there's more to come. But this is basically defining where your particles come from. So by default, you have the cone, and you also have the donut, box, sphere, fairly standard, and as you'd kind of expect. More recent additions are the donut and the skinned mesh renderer. So now we support spawning particles from animated skinned meshes, which is obviously useful for character animation and having particles coming off characters. So that's super useful. I'll talk a little bit about that later on. But yeah, depending on which one you select, you also have a bunch of different subsettings for that relate to the different type. So worth noodling around with and figuring out lots of different options for that one. And then finally, the other default one that's enabled is the renderer. So the renderer is obviously how you're rendering your particles. It comes with a default particle material. You also have the option of adding a trail material in the renderer as well. Trails are a somewhat recent addition to the particle system, which I'll get into later on. And yeah, so lots of different options. there's a lot of cool stuff with custom vertex streams. I'll briefly touch on later on. But for now, I'll say, for example, just switch this to stretched billboard so we have something reasonably easy, interesting to look at. Okay, so that's some of the basics. One other kind of fundamental thing that I will cover now is sub-emitters. So if I just grab our current particle system and duplicate that one, perhaps modify this emission so instead of it emitting over time, it just has a burst. Maybe just maybe not 30, maybe like 5 particles when the thing arrives, and I'll also change the shape to being a sphere, which is one of the most optimal. Okay, so sub-emitters are a module which I will enable now, and what they allow you to do is to define other particles to spawn on certain events. So we have a birth event, a collision event, and a death event. So pretty standard event types. And if you assign a particle system to that, it will ask you if you want to reparent to the new particle system, which you can do. And now we have this kind of crazy, not entirely realistic looking fireworks display happening, which, yeah, isn't fantastic, but it'll do the job. I'm going to switch this back to just being white so you can see the different elements popping out. It's, yeah, very simple system, but on death the particles are now emitting a new particle system at each point. I'll also disable looping as well, so that way that, yeah, the exploding fireworks at the end of their trail aren't looping. So yeah, that's sub-emitters. They're very straightforward, very easy to use. You can also define things that they inherit. So for example, I could inherit the color. So now every firework that goes up into the air, when it explodes, it will be exploding into the correct color and inheriting that kind of stuff. So yeah, super useful. Obviously, the more of these you use, the less performant things are going to be. So yeah, use them sparingly, I guess. And you know, you can quite easily get into crazy nested sub-emitter chaos where a sub-emitter then triggers another sub-emitter, which then triggers another sub-emitter. So yeah, probably best to avoid that where possible. But yeah, I guess use common sense, and most of the time you should be okay. Okay, so the next thing I'm going to cover is a relatively recent one. So we're starting to get onto the more interesting effects now. So this module is the noise module, and this really adds some kind of, I'm just going to disable this one. Yeah, really adds some interesting movement to your particle systems, which is really useful. Oh, it's also worth noting as well, if you have any questions along the way, feel free to type them into the chat, and we'll be kind of logging them down, and we'll kind of get to them at the end of the live stream. Yeah, but the idea is if you have any questions as we're running through, just note them down, and we'll get back to them. And if it turns out to be a question that's you know, something that we're not entirely sure of, we'll ping the correct people and get an answer to you. So yeah, just bear that in mind. Okay, so the noise module is pretty flexible, and it really adds a lot more kind of life to your particles. So now we've gone from having a kind of particle fireworks display, a very weak particle fireworks display, but a fireworks display nonetheless, to kind of almost like an effect of some embers flowing off a fire. By default, it's set up with high quality. You can modify the quality depending on performance as to what you'd like. Obviously, the lower the quality, the less convincing the effect. But you know, there's a lot you can do with tweaking and modifying them in order to get what you'd like. You can modify the strength, obviously, so you can turn them more into like some kind of crazy fireflies flying around, and you can modify the frequency as well to make them. I don't even know what they are at this stage, but yeah. So lots of options for modification, and making the noise look interesting and unique. In addition to that, you can also have a scroll speed as well. which is useful for making your particles move in kind of non-uniform ways. It's all using a Perlin noise, as you can probably tell from the preview there, and it's a variation on Perl noise that's super fast and useful. The other thing that's worth noting is that you have the octaves as well. So you can increase the amount of octaves, which kind of layers the noise on top of each other, and you can like define the scale of octaves as well. So you can add, like a really large noise and then a smaller noise below it and that kind of stuff really easily, which is worth considering. So yeah, noise is a good one to noodle around with. There's a lot of cool possibilities with it, and it just generally adds a lot more kind of a realistic look, depending on what you're going for. Like they're looking at kind of like weird fishes flying around at the moment, but yeah, worth playing around with for sure. The next one I'll cover is the trail renderer. So I mentioned this earlier, but if you go down into the renderer module, and if you go to trail material, you can define a trail material here. So I think I had this one, like a simple trail I'll set up. And I've set that up and nothing's happened, so you'll be thinking, wait, what's going on? But if you need to enable the module, obviously. So here we have a pretty interesting effect now, just by enabling that. There's a lot of options with trails for getting the right kind of effect you want. The texture mode in this case is just a stretch, so it stretches along the length of the particle. In addition to that, you can also turn off the renderer for the actual particles itself if you want to. Although in this case, that's just making them show a render error. But this is a feature that is coming, I believe. I think I've turned it off when I shouldn't have in this version. But anyway, there's lots of cool stuff you can do. If I go into the trail renderer and show you some of these, you can kind of tile the trails as they go up into the air, and you can also have distributed segments, etc. So lots of stuff, and you can also adjust the color over the lifetime as well. I've also got it currently set so they die with the particles, which is kind of not what I want. So if I turn that off, you can have it so that when the particles die, the trails kind of peter off and die themselves as well. So yeah, it's a little bit heavy performance-wise, the trail renderer, but that will be being improved over time as the team are able to optimize things. But generally, it's a nice effect. Okay, so with that done, I'm going to move into kind of more interesting use cases and that kind of thing. So I'll start with this one here, which is kind of animating particle effects. So those of you that were around for Ollie's talks the other day on animation, I believe you'll be familiar with the animation view. If not, yeah, it's a animation system within inside of Unity that allows you to create simple animations. So perhaps not something that you'd want to use for a full-on character animation, but more than adequate enough for a simple effect animation. So if I go and get my view here, I've got an asset that I picked up from the asset store, just a free science fiction door. And the effect I wanted to achieve was to kind of animate this door opening and then kind of failing to open and some sparks flying out to show that something's clearly wrong with this door. So if I hit play, you can see the door kind of opens up and kind of grinds to a halt and then stops. But what I've also done is I've gone in and added a particle effect to that. So this is the particle effect here. It's also using the lights module, which is a fairly expensive, but if used well, not too bad system. Definitely something you'd be wanting to use in deferred rendering, if possible. And the great thing about particle effects is that the vast majority of the options that you have in the particle system are exposed so that you can animate them within the animator, and it's actually quite performant, which is great. It's actually more performant and often than going in and modifying these values via script, which is cool because it really kind of empowers artists to make cool stuff with animations and particles. So what I've done is I've modified the position and the emitter values on this particle system. So over time, the particle system moves. It's a child of the door object, and it emits some particles at one point, and then moves to another point, and moves to another point, and emits more particles. So if I hit play now, with the particle effect selected within the scene, I can just press the play button on the animator, and it will automatically play through and loop the effect. So obviously it's a nice way of animating your effects simply and easily, and kind of tying it in with other animation effects that you're doing elsewhere. In this case, it's sparks coming off a door, but it could be a whole host of other things. It could be I guess weapon effects or whatever on your characters, or there's a whole range of possibilities, I guess. But it's worth bearing in mind that animating particle systems is a very efficient way of controlling your particles over time. It's also quite fun as well. It's worth noting that when you are animating these effects, depending on how you use the animation view, there's a bunch of different ways of adding new properties. So for example, we've got the sparks effect position and the sparks effect particle system emit values here that are exposed as properties. You can add a property and go through this way. And if you go to the door, for example, here we've got the sparks effect and then the particle system, suddenly you're exposed to a huge amount of different options for all of your modules. So it's not necessarily super easy to go in and figure out exactly what you're wanting to open up. So that being said, if you go and hit the record button and then put your timeline where you want it, so for example we could have some extra something going on here, you can then go into the system and modify values. So I could say and change the start size to, I don't know, 20 at this point. You'll notice that the background becomes red, and now the particles are set to be ridiculously huge, far too huge at that point in time. So instead of having to dig deep into the various hierarchies in the animation view, it's often easier to just hit that and then modify the value that you want to in the inspector, as you would do naturally. In this case, I've basically ruined the effect by making the start size ridiculously high. But yeah, so that's a little bit of an overview of animation. It's very straightforward to do, very simple, and it's quite performant. So definitely consider doing it in your productions, because it's really great for adding effects, and it also gives the artists control of that kind of stuff, which I think's good. So next on the list, I'll go through and cover a little bit about the skinned mesh stuff. So I've got a simple scene here with Adam, and I've got a rain effect coming down. So nice simple rain effect. I'm also using the collision module. If you're not familiar with the collision module, it's pretty cool. There's a lot of good stuff you can do with collisions in Unity. In this case, a lot of simple stuff, but it's just colliding with objects in the scene, and that's causing the particles to die, and it has a sub-emitter on collision. So when the particles collide with the floor, in this case, they're spawning these different particle systems to splash around. Simple enough. In addition to that, I've also taken that same effect and I've applied it to the Adam model using the skinned mesh renderer shape in the particle system. So in this case, it's emitting specifically from the torso. Perhaps Adam isn't the best example because he's a robot, but if you had a fully skinned character, it's an easy way of having it so that particles can be spawned from the character. So whether it be the character's caught fire or whatever, really, it's simple and easy to do. So if I just hit play, you'll see that we have both of those effects going on at once. And yeah, so super easy to achieve that kind of effect, where if your character kind of jumps into water and then gets out of the water and is dripping for a period of time, or as I said, if you wanted to set your character on fire, that kind of thing. Worth noting is that the 3 options for where your particles are emerging from, the vertex, edge, or triangle, I believe it's in order of how optimal it is. So triangles are the least performant, whereas vertexes are the most performant. So something to bear in mind. There's also some notes on things that are coming in the future with regards to this kind of stuff, but I'll get to that at the end. Okay, so next up on the list, I have animated particle effects, kind of animated texture effects. So I have a particle system here that's using a very specific material that comes bundled with Unity by default. And if you're not familiar with how it works, if you set it up, the defaults won't actually look quite right. So this is the Anim Alpha Blended material, which it uses a material with a texture, with a set of what am I trying to say? Like a series of animation tiles within it. So in this case, I've got my simple tile that allows you to, so we've got the different smoke effects here coming on. So we have 4 frames of animation in this case, so not a lot, and it's just a 512 by 512 texture. And what I've got going on is I have this Anim Alpha Blended material associated with it, and then I'm using the texture sheet animation module. So it's a 2x2 grid, and I can say I want you to animate the whole sheet, and there's a bunch of different options for flipping UVs and cycles and that kind of stuff, and what the start frame is. But the kind of secret thing that isn't necessarily readily apparent is that it's also making use of custom vertex streams. So custom vertex streams, if you're in any way familiar with writing shaders, are definitely something that you can make use of with particle systems. In this example one, the Alpha Anim Blended, it's basically taking on a second UV and a blend, and you can add these as you'd like, all these different values you can add. By default, if you assign a material with the Anim Alpha Blended, these custom vertex streams aren't set up, so it's something that you need to be aware of. Like if you don't have the UV2 and the Anim Blend set up, and you remove those and you set up a particle effect with the Anim Alpha Blended, you're still getting the animation of it going through because you've got that module enabled, but you don't have the actual blend effect happening. So do make sure that you enable UV2, and that will get the next UV, which is kind of allowing for the blend to happen. So you have the 2 sets of UVs, one on the current frame and one on the frame that's coming, and then you have the blend, which takes care of blending between them. So yeah, it's a pretty flexible system. There's a lot of cool stuff with that. That's kind of like a little bit of an insight into that side of things when it comes to custom vertex streams. I will also mention a bit of that later on when we go into some of the stuff that's coming soon. But that's something to be aware of. Animation is possible, and also alpha blended animation is possible as well. We also do support the sprite sheets as well. So if you want to use animated sprites, you can use that now in Unity with the particle system. And the real benefit of that is that it kind of retains the pivot information and all of that kind of stuff, which wasn't that possible before. So it's quite an optimal way of bringing in your 2D sprite effects and turning them into particle systems. Okay. Next one to cover, I will briefly mention, is the collision module. So I have a simple project here which just has a particle system that's firing particles at a sphere. So if I just hit play, you can see what's going on here. So it's just a sphere with a rigid body, and the particles are flying up and hitting it and applying a force to it. So traditionally, this is something that you'd need to kind of program yourself. But with the collision module, you can kind of set this all up without... Oh, did it just fly off? Oh well. Yeah, you can set it all up without having to write a line of code, which is kind of useful. So what we have set up here, we have it set to be a collider to collide with world in 3D mode. You can also use 2D as well, so all of this applies to 2D particle systems and 2D colliders, which is great. And if you enable dynamic colliders, it allows you to interact with the physics system dynamically as well. In this case, I've got it set to apply a collider force upon impact. So every time a particle hits the collision object, you can trigger it to do something. In this case, it's triggering the collider force of 200 to be applied, but that's kind of happening out of the box without having to do any special code or anything like that. That being said, we do also have a collision callback in the API. So if you want to do more advanced behaviors or have it so that your particle systems are actually in some way, part of the gameplay. So I don't know whether you're like firing water at something to stop a fire, or I don't know, any kind of effect really, but you want it to somehow affect gameplay, or maybe using it as kind of like a system for the firing of weapons and adding damage or something. So there is this part of the documentation, which is the on particle collision. I'd recommend reading up on that if you're interested in triggering various effects based on collision. But yeah, that's pretty good, and you can do a lot of cool stuff with that. Yeah, so that's collisions. In addition to that, because of the fact that we support collisions, using the Unity physics system, we also support triggers as well. So the triggers, as with regular Unity physics stuff, you can define that a collider is a trigger. Likewise, with the particle system, you can have trigger effects happening as well. And similarly to how the physics system in Unity handles different collision events, so whether or not there's something inside it, whether it's outside it, entering or exit, you can choose to either kill them. So for example, if any particles are found inside, they will be killed. You can also ignore that effect, or you can trigger a callback as well. And again, that's something that's all in the documentation. So if you wanted to have, say for example, some kind of an effect where a character that, say for example the Adam demo that I had with the rain, if I wanted it so that only water would be coming out of areas on that mesh that were up to a certain point, I could use trigger volumes to perhaps do that. So you wade through a small stream and then get out the other side, water would only be coming off areas of the mesh that are above a certain point or something like that. But yeah, there's a whole bunch of different stuff you could do. You can modify color and all that kind of stuff, but a lot of potential for the trigger module. You can do a lot of stuff with it. So yeah, that's the trigger module. So now we're kind of getting towards some of the new things. So I'll just bring up this quick demo here. So this is 2017.2 still, and this is a new module, or a new addition to a module. So this is basically the limiting velocity by size. So this is a new feature inside limit velocity over lifetime. So if I just restart this kind of explosion effect, you'll notice there's kind of these globules of all different sizes, so smaller ones and larger ones. But what you'll notice is that the effects of kind of drag are kind of equal on all of these, regardless as to what they're applied to. So the larger ones can fly really far, and so can the smaller ones, and it doesn't really give such a realistic effect. But if you enable multiply by size, and hit that, what you should start to notice is that the smaller particles reach further and the larger ones have more drag on them. So it just kind of leads to a much more believable effect, especially with kind of explosions and the like. If you have like, you know, debris or whatever flying off from your effects, having this little option there checked can really be useful. Okay. So I'm going to talk a little bit now about performance optimization. If I bring up a different particle system, maybe this one. So this is where we were right at the beginning. So we've got a similar kind of an effect where we've got this kind of stream and we've got the particles flying up in the air, and then dying out and spawning some particles at the end. So there's a whole concept with the particle system that's pretty clever, where it has this automatic culling system. So if a particle system has certain modules enabled, it's or certain modules not enabled, it allows you to automatically cull that particle system, mainly because of the fact that it's predictable, and it's a procedural particle system because of the modules that you've chosen. With that in mind, if that particle system is then kind of out of the frustum or is elsewhere, it won't need to be calculated, so it can be automatically culled, which is great because it all happens automatically. But if you don't know whether or not your system is using this automatic culling, there's a little icon hidden away at the top of your particle system, just here. So this little exclamation mark and a speech bubble. If you hover over it, you'll notice a little tooltip pops up and it says automatic culling is disabled because, and then we have the fact that the noise module, which isn't a module that can be automatically culled, and the sub-emitter as well is something that can't automatically be culled, and the trailed module. So obviously a lot of the cool parts of this effect, unfortunately. But if I switch off some of those, we'll see now that disappears, and that now means that this particle system will automatically be culled off screen, which is definitely worth knowing, because if you didn't know that, there's certain things that you can do to help performance. It's worth noting as well that it is possible to work around that. So say you had a system that you really wanted to have the noise and you really wanted to have the sub-emitters, and perhaps you wanted trails, and collision as well as another module that that disables automatic culling. If you still wanted those, it's definitely possible to work around that and kind of write your own system that uses the culling group API. So this is a somewhat recent API that allows you to get access to the whole culling group system within Unity. So you can make use of the culling group API to then cull your particles when they're off screen or using occlusion culling, even if they aren't set up to automatically work. Obviously, if you had like gameplay critical collisions and that kind of stuff, you would want to not cull them when they're off screen. But it's one of those things that's worth knowing, that if you have some kind of an effect with sparks or something, or something that isn't critical but it's using some of these modules that disable the automatic culling, it's worth knowing that it is possible to use the culling group API to get some performance out. There's a really great example of that from a video from the guys from Unite Europe 2017, I believe, and that's on the Unity YouTube channel. So yeah, definitely check that out. I think if you just search for Unite Europe, you should be able to track that one down pretty easily. And that's got a lot of great examples for performance optimization as well. One other thing worth mentioning as well is that curves can be optimized as well. So if I let's have a look. If I perhaps change the start size to be a curve and go into my curve editor here. So along the bottom, we've got a bunch of default curves, which are all fairly optimal and good. But one of the most expensive types of curves is a curve that uses more than 3 points along its time frame, or perhaps one that doesn't quite start and finish at the beginning point or end point. And they become a little bit more performance hungry. But with that in mind, if you do enable one of your particle systems with a curve, and you're not sure whether or not it's an optimal curve or not, you can fix it. So hidden way down here in the bottom corner, there's a little plus icon. And because of the fact that I've added multiple keys along this, multiple handles, and modified them around a bit, this thing appeared automatically. So if I click that, it'll try and repair the curve as closely as possible to something that's optimal. And oftentimes you'll find that there is, you know, a simple curve that you're doing that's maybe got an extra key that it perhaps doesn't need, and if you enable that, you might get a result that's a little bit closer to what you want, but is also, you know, performant and able to handle things as you'd expect. So there's a good example where if you've got something slightly off and you don't realise, that's going to be slightly less optimal, but if you press the button, it'll automatically fix that for you. So that's certainly worth noting. Okay, so I think we're doing okay on time. I've just got next set of things to cover, which is kind of roadmap and future stuff. So if I close down this version of Unity and fire up a different one, this one. So this is currently the 2017.3 beta, and if I just open this one, so the particle systems in general are getting a huge amount of love at the moment. There's a really cool bunch of guys working on particles at Unity, and they're doing a lot of really clever stuff and really cool stuff. So let me see, which one should I start with? I think I'll start with the unlit torch. So yeah, if I hit play, we've got a really fancy looking particle effect here with a torch. It's got some distortion effects going on. It's got HDR color, which is something that we've been needing for particle systems for quite some time, which is awesome. And it's using the new unlit standard particle shader. So much like that's the torch itself. That's using the other one. There we go. So yeah, the much like the regular standard shader that's being used for the actual metal torch, the particles unlit standard shader is included now in 2017.3. It allows for a lot of really awesome things that weren't available before. So yeah, as I mentioned before, you've got HDR color now, which is really useful. And there's also some really really useful things with like built-in fade, all kinds of the standard, you know, color modes that you'd expect to see. There's also flipbook modes that are blended or simple by default out of the box. So all of the stuff I showed you with the custom vertex stream and that very specific material is now something that you can achieve by just simply setting up the standard shader, which is super good. In addition to that, this is something worth knowing. It's not necessarily super obvious, but because of the fact that you're modifying all of these elements on the standard shader, and you know the way Unity works with its standard shader of having all these different options that only are relevant at compile time. So for example, the blended effect, which we've got going on this fire, it automatically tells you what required vertex streams are there. And by default, you are able to click this button here to apply that to systems, which is really useful. So all of that step I went through with setting up the custom vertex streams up here, all you need to do is once you've got your standard shader set up, hit that button and it'll apply it to all of the particle systems. So you don't even need to worry about going through and modifying and setting that stuff up, which is super useful and worth knowing about. What else have we got? So we've got another example of the linear drag here. This is a 2017.2 feature, although it's been kind of pimped up with some, distortion effects that are now possible with the standard shaders, and and some lovely fires. It just looks a bit nicer. That's what else have we got now? We've got ribbonized particles, which is a nice new feature. So if I just hit play here, so we're using a similar effect to the trail renderers here, although what's happening is that the particles themselves are kind of linking together to cause the ribbonized effect. So there's a series of particles moving up through the air, and those points are then being linked together with the ribbon. So if I were to say increase or modify the noise a little bit, it's got a very weak noise on at the moment as this smoke gently rises, but I can modify that and increase the size of it and the scale of it. Hopefully not too much, because it'll cause all kind of crazy things to happen. But yeah, so instead of the system with the trail renderer, it's using the particle points to kind of step through based on their lifetime in order to create this cool effect. So that's a nice one that's coming by default. Where else have we got? There are also a bunch of systems for external forces coming, which is really nice. So you'll be able to do kind of orbital effects and that kind of stuff, and you'll be able to modify the speed of a particle over time, and also modify it so that the speed can go into minus values as well. So you could have a particle explode and then kind of turn back in on itself just by using a curve in the speed, which is super useful. We also have the example of the lit particles standard shader. So this is super nice. So yeah, we've got the unlit torch, but we've also got the lit marbles in this effect. So we've got, using the standard shader lit, standard surface particle shader, we can use lights to light these effects, these particles, and get some really cool looking effects really easily. And obviously this is all linked up with the standard shader. So yeah, really cool PBR, fancy looking stuff. And super performant as well. But yeah, another one that I'm just going to mention that's coming down the line is being kind of experimented with and is looking really cool at the moment, is something to do with the emission of particles using a texture. So the idea is that if you have a texture applied to a mesh, you can assign that texture to then kind of decide how particles are being emitted, and also take on things like color, but it's really flexible, so you can do what you like. So if you wanted to, you could have, say, like have like a character mesh maybe, or like a box, for example, and then have the alpha on the alpha channel of this texture, and use that as the way that particles are spawned. So they'll only be spawned from the areas that have say alpha set up, or use whatever channel. So yeah, you can do a lot of really cool stuff with emission. Say, like, I don't know, on a character's face, for example, you could have fire coming out of their eyes, and all of this kind of stuff. In addition to that, you can also, use the system to inherit color as well. So if you wanted to create some kind of, I don't know, Star Trek style teleportation effect, where all of the texture color data from specific points around the mesh is inherited by a particle, that particle kind of then flies off and does its thing, and then yeah, it's a pretty useful one. Okay, so I think that's kind of come to the end of what I had to cover. So thank you, and sorry for the weird delay in the beginning there. We had things set up, and I think the link that went out was set up slightly incorrectly, but we got there in the end. So I think what we'll move on to now is trying to take some questions if we have a little time. And let's have a look. Obviously, if there's any questions that come up that I don't necessarily know the answer to. We will try and arrange to get back in touch with you directly with the answer from our dev team. So we've got some questions here. What is the less performant mode, curve or random between two constants? Oh, good question. I believe a random between two constants is a little faster than a curve. As part of the talk at Unite Europe, there is a really nice, helpful graph that shows you which is most performant. But off the top of my head, I believe it's the random between two constants and then the curve that is more performant. Okay, next question is, do I optimize my particle system by changing max particles from 1,000 to 30 if I will only use 30, or can I leave it at the default 1,000? If you're only using 30, it seems fine to do it that way. Just leave it at 30 and leave the default at 1,000. I guess it's just a way of kind of constraining the upper limit, so you can't accidentally, type an extra 0 somewhere, then suddenly have Unity grind to a halt. It's kind of more of a safety feature for editing. Although that being said, if you have a very complex particle system where you want to, reduce things down so you're never hitting a certain point or that thing, it's definitely worth using the max particles at that stage. But yeah, if you're only using 30 and you know that there's always only 30 there, it's fine to just leave it at the default. Okay. Suppose I have a bunch of sub-emitters, but they are disabled. Will they still break performance drastically compared with a particle system without sub-emitters? That's one I'd have to double check on, but I believe that if they're disabled, they won't be taken into consideration. But I would need to double check on that just in case. But my instinct would be that if they're disabled, they wouldn't be. It shouldn't break performance compared to one without. And the next one is, in animation preview mode, should I select all of my animated particle systems to view them? Good question. I'm not entirely sure if that's supported or not. I'll have to double check. If you have your particle systems in a kind of parent-child hierarchy, I believe that the children in the particle system, and if you select the root or the parent of the particle system, all of the particles that are within that family are displayed. So that might be one solution to doing it with the animation. Obviously, then you've got the parent-child structure, which you might not be looking for. If not, it may be a case of just setting up a scene where you just have the option to hit play and see the effect in play mode. So if you animate and set up your particle system with its multiple sets as you go, and then in terms of animation, do the stuff in the end. I have to double check, but I think you need to have the particle system selected in order to preview it. To clarify, animation usage to control particle systems is more performant than scripts. Yes, it is. Apparently, I'm not entirely sure exactly how widely different that is. I'd have to check with the numbers, but yeah, it's faster to do it that way than having to grab it with from script, modify the value, and then send it back. With animation, it's just kind of doing it underlyingly. So it's it's actually more performant to animate than it is to control with script, which is pretty cool. Is the distortion effect in particle stroke standard unlit based on a grab pass or some other technique? That's a good question that I'm not sure I know the answer to. Let me see. The torch. Let's have a look. I wonder whether it's reflections. I think it might be using... that's the torch. That's the wrong one. No wonder. So fire, it's got blended mode, camera facing, transparent hue and albedo, a grayscale fire. I'll have to double check on that one. I can ask the guy who set up the example and see exactly how that's set up. I believe it's yeah. I'll have to double check on that one. I'm not entirely sure, so I'll get back to you. About the performance impact of the noise module, do you have any stats on it, especially when it comes to initialization, differences between the quality settings and scrolling speeds? Well, we do have like a test suite that the particle system team use to test all of their particles. So I'm pretty sure they have the data. So it's the kind of thing that we'll be able to get over to you in terms of the general options available to you. But it's the kind of thing that the team have, and they have a whole test suite specifically for recording changes and seeing what's performant and what isn't. So yeah, that's something that I'd have to get back to you on, like on specific values. But that's the kind of thing that we could ask the team and get those over to you guys. Okay. Let me see. I'll just have a quick scroll back to see if there's any other that I missed. I think Chris seems to have caught most of the things. So awesome. Few last things. Oh, one last question. I may as well do it. Are there any plans to implement emission from a list of transforms in the emission module? Ooh, that I don't know, but I'll that's one to quiz the team about. That could be useful. It's the kind of thing that you would be able to modify and do, through animation if you were wanting to kind of reparent things perhaps. But yeah, one worth considering. I'll try and find out on that one. Okay, so a few last things to go through. So there's if I just switch back to the screen a sec. So we do have a little survey, which is this fantastic URL, surveymonkey.co.uk/R67QFQM. So if you have the time to go through and just answer a few questions about this, it would be very much appreciated. I'm going to find out if I can get hold of these projects to send out to folks. So if you do fill in the form, we'll be able to then send out the project for the 2017.3 stuff. If I can, so I'll need to double check whether or not it's something that we can distribute to folks. But it should give you a good kind of overview of the 2017.3 stuff that's coming rather soon. I'm not sure we have an official date yet, but it is coming very soon, this new stuff. There's lots of really cool additional stuff coming up in the future, so definitely keep your eyes on the blog. There's some really cool particle system stuff coming up down the line. The team are working on some really fantastic stuff, so good news for VFX folks and people who like playing around with particle systems. Okay, so I think that's it. So thanks a lot for tuning in, guys, and apologies for the strange disruption at the beginning there. Hopefully we'll get that fixed down the line. But yeah, thanks a lot, folks.